The average velocity is another physical quantity which is defined as the displacement divided by the time interval. This physical quantity is actually a vector quantity because it is directly related to another physical quantity, which is the displacement. Once the displacement is determined, as in our example 270 I hat meters, one can determine directly the average velocity by dividing the displacement by the time interval, which is 4 seconds minus 1 second, which is 3 seconds. Thus, the average velocity as a vector quantity equals 90 I hat meter per second. So the average velocity has a magnitude of 90 meter per second with the direction due east. This is an application on the average velocity of a particle. In this example, it will be shown that the average velocity of a car will have a negative sign. So the negative sign will indicate the direction of the average velocity towards west. In this example, a service car was at point P1, which is located 300 meters from the shown origin after 1 second of its motion. It passed point P2, which is 30 meters away from the same origin at time 4 seconds of its motion. What is its average velocity? In this example, the initial position of the car is given as 300 meters due west, and the final position is also given as 30 meters due west. In order to find the average velocity, we need to apply the relation that says average velocity equals the displacement delta r divided by the time interval. In this example, we need to find the displacement, which is minus 270 as we subtract the final position 30 meters minus 300 meters. However, the time interval is 3 seconds as we subtract the final time 4 minus the initial time 1. And then writing down the result for the displacement, which is minus 270 meter in the negative direction, and divide that by 3 seconds, we'll get an answer of minus 90 I hat. This means that the average velocity has a magnitude of 90 meters per second, and its direction is due west. Before we define the average speed, let us see what is the difference between the distance, which we presented before as the magnitude of the displacement, and this displacement is actually a vector quantity, and between a distance where there is no mention at all of direction. And in this case, this distance is a scalar quantity. Knowing this difference will allow us to define the average speed and differentiate that from the average velocity. Well, again, we know that the average velocity is a vector quantity, which is equal to the displacement as a vector quantity, which has a magnitude called distance and direction, divided by time interval. For the average speed, it's actually the total distance divided by the total elapsed time, without any mention to a direction in this case. So the average speed in this case is a scalar quantity. To understand that, let us look at the map where there are two routes for a trip by car from Amman to Irbid. The first route, the orange path, is 92 kilometer distance. Without mentioning any direction, this represents a scalar quantity. However, the other path, which is via Al-Mafraq, has a different distance of 111 kilometer. If we decided to find the average speed in both cases, see, we should have the time for each trip. There is a third path, which is the one from Amman to Irbid, which is a straight line one, which is this one. This is the shortest distance, which is considered as a flying distance by plane, is 67 kilometer. In this case, this might represent a distance as a scalar quantity if the direction is not mentioned. However, if the direction is mentioned, this shortest distance between Amman and Irbid will represent the magnitude of the displacement vector. Now, in this case, we can find the average speed and find that the average speed has a value similar to that of the magnitude of the average velocity, because this is the only case where the distance coincide, same distance, which is 67 for both the average speed and the average velocity. However, the average velocity is a vector quantity and must be accompanied with direction. To elaborate more on that, if we decided to go from Amman to Irbid through this short distance and then come back again to the same place where we were in Amman, so the average velocity depends on the displacement, and the displacement represents the car where it was and then when it ends up. So since the initial and final position are the same, in such case the displacement is 0 and then the average velocity is 0. However, for the average speed, we should measure the whole distance from Amman to Irbid and multiply it by 2, and this result represents the total distance, and we have to divide that by time, the elapsed time of the trip, in order to get the average speed. And this explains how the average speed is different from the average velocity.